just were like brain teasers. So you get 0 over 0, you would try to manipulate, and they don't really fit the mold of the manipulation. They don't really fit the mold of sketching a graph. So I decided to take a day and just let's explore this and give them the time they deserve to wrap your head around them. So on the first one, if you directly evaluate by plugging in 0, which I will preface with maybe a little silly to do anyway, because when it says that you're approaching 0 from the right, something is up. But think about this, and I'll call on someone to answer the question. If I plug in 0, I get sine of 0, which is 0, and then the natural log of 0. What's the trouble? You can't take the natural log of 0. So clearly we're going to get an undefined. This function, whatever it looks like, and I'll be honest, I have no idea, that function is undefined at 0. So if something's undefined at 0, forget finding the limit at 0. But we can still look at the limit as we approach 0 from the right. Yes? So if I were to plug in a teeny, teeny, tiny number just to the right of 0, and calculus does weird things to us, so I'm just going to put a number line on it here. Just to the right of 0 would be like 0.0000001. Okay? If I plug in a 0.001, a really teeny tiny number here, what is the sign of that approaching? What's happening to the sign of values as those values get smaller and smaller, coming towards 0 from the right? It would approach 0. They are also getting teenier and tinier, right? Here's pi over 2. The sign of pi over 2 is 1, and the sign of 0 is 0. As I get closer and closer, these numbers are getting teenier and tinier, right? I'm plugging in teenier and tinier numbers, but the sign of them is also getting teenier and tinier. So now I'm trying to take the natural log of, I don't want to say 0 because we know that's undefined, tiniest positive number. And what happens when you take the natural log of a tiny, tiny, tiny positive number? From a calculation standpoint, you probably don't know the answer to that. But you do know what the natural log graph looks like, or any log graph, correct? Looks something like this. That's the natural log-ish graph. If I plug in the tiniest x value possible, what's my y value going towards? Negative infinity. The smaller the x value I plug in, the more that'll go towards negative infinity. So it's kind of like a domino effect. The smaller the x value I plug in here, the smaller this expression is getting towards 0. And the smaller this expression is getting towards 0, if you think about your natural log graph, the smaller the x I plug into that, going towards negative infinity. Does that make sense? Okay? So there's really, and I know that this is not what you want to hear, there's no work to show there. It is all mental. I mean, between my voiceover and like showing you this and discussing it, like I can explain it and that, but to show work for something like this is like pretty hard to do. Now, just out of curiosity, the graph of this, and this is what you can do on your homework to learn and make sense of some things, is look at the graph and make sure the thought process is actually accurate. Sine of x, so we want to be in radians. I'm approaching 0 from the right, so I don't really need to go too far left and right. We'll see what this does for us. And you can kind of see that as this. Now this is the graph of the overall function. This is not the log function anymore, but it does look similar. At least this section of it looks similar. So as I approach 0 coming from the right, you can see this start to go downward. And if you wanted to look in even further, you could pinch your window into negative 0.1 to 0.1. And maybe go from negative, I don't know how small that would be, negative 100 to 100. Oh, I kind of lost the feel of the asymptote by going too big on my y. Let's see what this does. No, you still see it, but you lose it. Maybe if I zoom in down here, I'll see it better. Yeah, you see it a little more accentuated there. But as with any vertical asymptote, the graph can only show you so much. Okie doke? Yeah. The graph doesn't stop. That's what I'm saying. That's where the calculator comes in with a few errors. Okay? Because there's no, it stops at 0, but there's an infinite, this is a weird concept. This is probably 1/1000th. There's an infinite number of numbers between 0 and 1/1000th. It's just calculator can't show you that much. I wish it would show you this just drawing down, essentially looking like it's one and the same with the x-axis, but they do just cut off just because of the quality of the computer. Bailey?
So you basically just have to know what the graph is like?
For a log?
Yeah.
Absolutely, yeah. And in a lot of these, you have to, it's a combo. You might have to picture, and I've done it at times where I've sketched the sine graph if we're exploring limits. So a lot of the parent functions that you've learned over the years, definitely. The log graph, exponential graphs. I mean, here would be an exponential. And these are just parent graphs, and maybe they're shifted a little bit, but it nothing too crazy. But the general shape and what the end behavior is, yes. That will definitely, that's option number 2 to manipulating anyway. If you directly evaluate, get an indeterminate, and manipulate, and it's not helpful, jumping to the image of the graph has always been second fiddle that we try. This is just doing a little bit of both of that, because it's like a composition of a natural log function and a sine function. So the sine function we didn't handle that way. I didn't consider what the sine graph looked like at all. But the natural log function I did. And it just kind of depends on the problem. So why don't you take a second with this, try to think through this, and then we'll touch base in a couple minutes and have a discussion and see where you guys ended up. When you think you have an answer or your best guess. All right. Andrew just left. I was going to ask him. Olivia, talk to me about your thought process here. Because you got it right. And so I didn't look much further at your paper. So talk to us. Go up to the board, would you? The answer was 0. What is going to be really tiny? X is going to be really tiny. You can write down things if you'd like. Well, I don't know if everybody else is going to be okay if you just keep talking at them. Is everyone good with that? Negative big. Okay. All right, so she handled the negative exponent. Beautiful. Any questions on that? Can you erase that? I did. My logic was exactly the same, but I'll show it to you. Instead of using big, I used huge. You know, same. Instead of using big, I used infinity, but same exact concept. So here was the original, and I thought, as you're plugging in a tinier and tinier positive number, here's what I wrote. It becomes 12e to the negative 2 over tiny positive. Okay? And then I circled that spot because you kind of have to work your logic from the inside out, just like Olivia did. Negative 2 over a tiny positive. And the tinier that positive number gets, and it will get tinier as we approach 0 from the right, the tinier it gets, the more times it's going to go into 2 with a negative out in front. So it's really turning into like negative infinity. Yes? And then again, I too, because of, well, I didn't handle the negative exponent first. I was just going to try to throw a number at this. Negative infinity, I just treated as negative 999999999, whatever. Okay? Then I handled the negative exponent, and it was 1 over e to the 9999999, which is a gigantic number, right? And this 1 over a gigantic number is essentially 0. I mean, it's going to be so close to 0, it's not going to matter, right? So that when you multiply it by 12, big whoop, like 1 billionth becomes 12 1 billionths. That all might as well just be 0. The multiplying by 12, if you're multiplying by something that's essentially 0, the multiplying by 12 doesn't really matter. I wrote 1 over huge, which will approach 0, which is 0. And that is exactly the logic that Olivia used. I then just graphed it just to be sure, and there's what the graph looks like. So we had to come at 0 from the right because a lot of you realize, like, you can't, clearly the graph doesn't exist at 0 because you have an undefined exponent. Does the graph exist to the left of 0? I mean, visually I don't see it, but it should, right? Any issues raising, like if I plugged in a negative 1? Any issues raising e to the second power? No. Times 12? I just think it's off my graph. Yeah, it would be, well, right. So if I went from negative 50 to 50, I think I'd see, yeah, there it is to the left. It does exist to the left, I just didn't see it. Okay? And no one expects you to know what that graph looks like. But I do expect you to think through this process and what happens to each portion of the equation, and certainly make sense of it by saying, oh yeah, see, that is what it does do on the calculator coming from the right. Okie doke. Good work, my 0 people. All right, try 3. I think you got the right answer. What'd you get? Oh, no. That's not where I left you off. I left off looking at your paper when it said 1 divided by 0.001. And what would that indicate? 1 divided by a teeny tiny number. No. 1 divided by a teeny tiny number? Infinity. 1, when you divide by a tiny, tiny number like 1/100th, is 100. You divide by a tinier number, 1 divided by 1/1,000,000th is a million. So the overall value is getting bigger and bigger and bigger. So, Marissa, I still want you to do it because you were there. You obviously were correct up until that point. So can you go up and explain how you got there? Raise your hand if you got infinity. Good. Okay, write it down. Oh, shoot, class is over. Never mind, sit down. Give me 1 minute. I think what I'm going to do is I'm also going to record period 9, and I'm going to do 4, 5, and 6 with them so that you guys can all watch all of these explanations. But let me quickly, despite the bell, let me go through this explanation. So I keep change flip. So I kept the secant, but I did write it as 1 over cosine, changed and flipped, which gave me 1 over x cosine x. Okay? When I plug in 0 outright, clearly it's undefined. Now, undefined, as opposed to indeterminate, is an indication that the only way we're going to get more specific is with infinity or negative infinity, first of all, okay? So what I then thought about was for 1 over x cosine of x, 1 over the tiny positive to replace the x because I'm coming at 0 from the right, and then the cosine of a tiny positive. That tiny positive is still approaching 0, and the cosine of 0 is still 1. So it just ends up being 1 over a tiny positive number times 1, and 1 over a tiny positive is infinity. Hold on, I'm going to give you homework. There's the graph of it. You can see that on there as well. I am giving you just a packet of practice problems. Kind of treat this as like a review sheet of sorts. You may see some questions repeated. There's only 13 of them. It's a packet. There are only 13 questions. Okie doke? Tori, and you do check on the Chromebook, by the way, believe it or not. Did you imagine such a thing? Listen, you guys, I'm trying to get out of my comfort zone and do fun activities. Guess how much thanks I got yesterday from my 5th period class?
Not a lot, I'm guessing.
I put so much work into getting that fun activity ready, and they were like, they just prefer me to just talk and give them notes. It's fine. But I'm doing it again. Is it locked?
No.